Hello, space enthusiasts! Astronaut B here again. Today we will continue to explore even more tools that can be used with loops. Our onboard computer detected an asteroid field that we need to pass through. But don't worry, we'll be using break and continue statements to help us to get around these obstacles quickly. We will also utilize logical operators within our loop condition and learn how to juggle multiple counters within a single loop in order to be sure that all of our systems are running at safe levels. Let's buckle up and launch into this programming adventure. In my space missions, efficiency and precision are crucial, and these skills are also necessary when programming. Sometimes during a loop, I need to immediately stop the repetition sequence in order to respond to mission-critical conditions, like diverting my course when encountering an unexpected asteroid field. For this, I will use the break command. The break command stops the loop immediately, even if the condition has not become false. Here is some code we can use to execute this emergency move. If we look at the condition, it is always true. You may think that this will create an infinite loop, but since we have the condition within the loop with a break command, we have a situation in which it will stop. The loop will continue to execute until an asteroid is detected. Then, break exits the loop, and the emergency move is completed. Nice maneuver! Let's try another example. In this situation, we will do a while true loop, and inside the loop, we will check if a variable called oxygen level drops below 50. If this happens, we want to break the loop, and outside the loop, we want to print oxygen low. Pause the video here and give this a try in your guided notes. Great job! This is how it should look. We start with a while true loop. If the oxygen level drops below 50, we exit the loop. Then oxygen low will be printed to the screen. Let's take a look at another helpful tool that we can use with loops. The continue command allows me to immediately begin another repetition of the loop, skipping any other code that may be after that command. This helps me ignore less critical tasks and focus on repeating essential commands. Once in a while, I'll get a mission that asks my crew and I to search through space and log what we find. If we find space debris, we log the debris. But if the area we are searching is clear, we log that as well. Here's how we can do that. First, we will continue to log what we find in space while we are in the search area. If we detect space debris, we will log that debris and then continue. This causes the code to immediately jump back to the beginning of the loop, rather than continue moving further into the code. We don't want to log debris and log clear in the same area, as that would be confusing. The next time we run through this code, if we don't detect debris, the log clear function will run instead. And then the loop will repeat after that statement. This is another way we can alter the flow of code within a loop. Now you can try one. We are developing a new asteroid sentry system. We have these 3 functions to utilize. Check asteroid returns true or false if there is an asteroid approaching. Destroy will destroy an incoming asteroid. Finally, scan sky will change the portion of the sky to search. In a while true loop, we want to check to see if there is an asteroid in the sky using the check asteroid function. If this is true, we want to destroy it using the destroy function. At this point, we want to skip the rest of the code and run the loop again. Otherwise, we will place code in the loop that changes the portion of the sky to search using the scan function. Pause the video here and write a loop to do this in your guided notes. Okay, let's take a look at your code. First, we use a while true loop to continually run the code. Then, we write an if statement to check if there is an asteroid in the sky. If this is true, we call the destroy function to get rid of any of those pesky asteroids in the same area. We use a continue statement to skip the rest of the code and continue to destroy asteroids. But if there is no asteroid, we don't skip the next code and instead run the scan function to change the area we are searching. Out here in space, decisions often hinge on several factors. I use the and or logical operators to make complex evaluations in my loops, ensuring that all necessary criteria are considered before I take any action. Let's take a break from the break and continue commands to review logical operators and how they can help us in loops. Do you remember what the and logical operator does? That's right, and is used between two conditions, and if both conditions are true, the whole condition evaluates to true. Otherwise, the whole condition evaluates to false. What about the or logical operator? Do you remember what that does? Great! Or is used between two conditions, and if at least one condition is true, the whole condition evaluates to true. Otherwise, the whole condition evaluates to false. Remember, an or statement is only false if both conditions are false. Managing my spacecraft's power resources involves multiple checks, so I'll have to use a logical operator to make the correct decision. I would like to write code to see if my battery is low and there is a power source available. If so, I'll charge my battery. I'm currently developing a program that checks if my battery is low and whether there is a power source available. If these are both true, I will continue to recharge my battery. Once the battery is no longer low, the loop will end and it will stop charging. This condition ensures that I only recharge the battery when it's low and there is enough power available to charge it. Now you try this one, this time using the or logical operator. While space debris or asteroids are visible in the sky, I would like my planet security system to destroy them. Write code to call the check space debris and check asteroid functions. And if either of those are true, call the destroy function. Pause the video here and write the result in your guided notes. Excellent work! Your code should look something like this. While check space debris equals true, or check asteroid equals true, we will call the destroy function to destroy that object. In my spacecraft, I have to monitor several resources at the same time. Remember, counter variables can keep track of how many times a certain condition has occurred. Utilizing multiple counters in my loops can help me keep a vigilant eye on multiple situations. Take this, for example. I have a system that needs to keep track of the oxygen level and the water level in my engine cooling system and trigger an alert if something is wrong. First, we initialize our counters for the oxygen level and water level to the default amount, which is 100. Then we begin a loop that continues while oxygen level is greater than 50 and water level is greater than 50. Inside the loop, we check the function to see if our oxygen is depleting. If so, we reduce our oxygen level by 1. We then do the same for our water level. Outside the loop, we have an alert that will trigger. This way, once either the oxygen level or the water level gets below 50, the and statement will become false. Then the loop will stop and the alert will sound. In this loop, I'm repeatedly tracking both oxygen levels and water levels, lowering their counters as they deplete and triggering an alert if any resource runs out. What if we also had to check if the pressure is at 25 or lower? In this case, the pressure would begin at a value of 0. How might we change the code to accommodate this? Pause the video here and try this out for yourself in the guided notes. Wonderful! Here is what your code should look like. We now include an additional condition which checks that the pressure level variable is less than 25. We also include an if statement that checks if the pressure is rising, and if so, we increase our pressure level variable by 1. For this task, we will modify the code you've done previously for harvesting apples from our apple trees. While the robots have done a great job picking apples, we have run into a problem. Once the boxes on the rover are full, the robot keeps picking them and the apples are falling to the ground. Using the tools we have learned in this lesson, how can we stop the loop when the isFull function is true? Give it a try and then finish the other apple pie tasks in this section. As we dock back from our journey, I hope you've gained insightful knowledge about these new looping tools. We can use the break command when we need to stop a loop immediately. We can also use the continue command to skip some code within the loop and begin the loop again. When code gets complex and we need to check multiple conditions to determine whether or not to keep looping, we can utilize logical operators in the condition of the while loop. Finally, when we need to keep track of multiple attributes, we can use multiple counters within our loops and choose to break the loop when they reach certain values. These techniques are like navigational aids in the vast universe of programming, helping you write more efficient and adaptable code. Be sure to complete the programming tasks, practice questions, and extension activities before moving on to the next lesson. And remember, in the universe of coding, the possibilities are infinite. See you next time.
Hey, hey.